Alright, we've got a division problem here. We have a complex expression because we have a complex number in there. We've got two complex numbers in there. We know that because we've got this real part, and then we've got this imaginary part. That's not just a random variable I. That's the specific symbol used for an imaginary number I. So we've got two complex numbers dividing, and we need to simplify this. Well, the convention is that we don't have a simplified expression if there's an imaginary in the denominator. Similarly to if there's a radical in the denominator, that's not accepted as simplified either. And the strategy that we use to rationalize the denominator is similar as when we did radicals, except this time our conjugate looks a little bit different because we're dealing with complex numbers. So I need to get rid of the imaginary in the denominator, and I'm going to pick the conjugate. The conjugate of an imaginary, or of a complex number, is choosing the values, keeping them the same as what the denominator is, just like what we did with radicals, and then changing the operation between them to be opposite of whatever it originally was. So we had plus, and now we're going to do minus for our conjugate. And then we use multiplication, distribution, to multiply the binomials in the numerator and the binomials in the denominator. So let's go ahead and do the numerator first. So I like to do first to first, distribute that 2 to that 1, and we'll get 2, and then distribute the 2 to the negative 3i minus 6i. Just like if that was a 3x, we'd get minus 6x. You just treat the i's kind of like a variable while you're doing multiplication rules. Then, we've got to do the minus 4i to both terms in that second binomial. And we get minus 4i and plus 12i squared. Well, right off, I'm happy about the 12i squared because I know that an I squared is the same as, it's equivalent to a negative 1. So I'm really saying 12 times a negative 1. And all that does is change my 12 to be a negative 12. And now I have a negative 12 and a 2 that are like terms. They're both numbers, so I can combine those. 2 minus 12 equals negative 10. So I've got a negative 10. And then I also have like terms here with the 6i and the minus 6i and the minus 4i. Minus 6 take away 4 more. That means I've got negative 10i. So I'm going to write negative 10i. And you write the real part first. That's the general form for a complex number. So we wrote the negative 10 first. That's the real part. The negative 10i second. Okay, so numerator finished. I'm going to erase this work down here. And now let's do the denominator. Now the cool thing about the denominator is because I used the conjugate, I don't need to multiply all 4 times. Just like in the numerator, I don't have to do 4 multiplications. I just need to multiply the first terms and the last ones. And that's because when you multiply by a conjugate, the middle terms end up being opposites and turning to 0. So 1 times 1, 1, and the 3i times the negative 3i minus 9i squared. Again, I've got a negative 1 where that I squared is. So we've got 9 times a negative 1. That changes my minus 9 to a plus 9. So we've got 1 plus 9. And that's all I have in the denominator because my middle terms that had i's in them canceled out. So 1 plus 9 is 10, and I have a nice whole number. Not only is he rational, he's a nice whole number. Alright, now, after all that work, we aren't quite finished yet. We're finished with all the new stuff, using all the imaginary properties. But now, I notice that I have a 10 and a 10 in the numerator, and a 10 in the denominator, so there's a common factor. And I can say, hey, my top two terms have a 10 in common. So if I divide by 10 and write my leftovers, I've got a -1 and a -I left. Well, now I've got this 10 multiplied, because whenever you have a parenthesis, a number next to a parenthesis, that's known as multiplying. So 10 times this binomial, and then divide by a 10, because that's what my denominator is. So really, these 10s turn into a 1, because 10 divided by 10 is 1. So my final answer is -1 minus I.